let's talk about how Python handles if and else. So I'm on the Linux machine. I'm going to make a directory. Make a directory Python if else. Go into that directory. Make a file that just has some demo code. So again, we don't need to import anything for this. This is just straight Python. And let's think of an example program that says, asks your favorite color. So we'll say color equals input. What is your favorite color? And as we've seen before, we can just print the color. But what I really want to do is give a different message based on what color it is. And if I don't recognize the color, because I'm only going to have a few cases, it'll just give like a default answer. So the way we do that is we have to ask the question if, and then color, because that's the thing we're going to ask about. And then what we want to really ask is if the color is equal to, say, blue or green or something, we'll give a specific answer. Blue. All right, so what just happened there was the double equal sign is how we say is the same. Single equals, you see above, single equals means change a value. So here color is changing to whatever the person types. So we can't really use equals in an if because we don't want to be changing the color. So we use double equals to ask if the color is the same as something else. So are these two things the same is that question. And then we have to follow that with a colon. Now, the way Python works, unlike other languages where you would have like a squiggle brace and semicolons and all this extra stuff, Python uses indentation, so tabs. So whatever you want to happen when color actually does equal blue has to be tabbed inside of the if. And you only want to do one tab at a time. So all of the code that we're going to do in this if will be tabbed just once. So if the color is blue, then I'll say, well, that is also my favorite color. Else, that means it's not blue. So print this message. Notice the else lined up with a if. We don't want to put the else with a tab because then it doesn't really line up with that if, so it doesn't know which if it's supposed to go with. This doesn't make any sense. So the if and else, if you do have an else, needs to be lined up the same. And then notice the print in the else is also indented because that's what we want to happen should the else be true instead of the if. So I'll save the file and run it. Blue. So we get that message, otherwise we get that message. Or, obviously anything else, we get that message. Now notice actually, if I type capital blue, we still get the default message. So let's make blue or capital blue be acceptable. So what we can do is put an or for the other case. There's other ways to do that. Of course, you can lowercase whatever they type and then just check if it's lowercase blue. But I wanted to show an or, so here's how we do an or. And notice you have to ask the question twice, like completely. Color equal blue or color equal capital blue. You can't really say color equal blue or blue. After the or, you have to ask the whole separate question. All right, let's run that. So now if I type capital blue, it still works, or lowercase blue. Okay, now you can have another case. If it's blue, it's one thing. If it's green, we'll see something else. Otherwise, default. So this is where we could do a separate if, but we really want like if or this or this or this else. So we call that an elif. Elif is actually an else and an if combined. So this happens when it's not blue, but it's not the default case because I still have an if. So if it's blue, that's one thing. If it's green, here's our second case. whatever, color of trees. Else, it must be neither blue nor green, and so you get default message. So that's the role of elif. And so if I say blue, you get that message. Favorite. If you say green, you get color of trees. If you say anything else, red, you get that's interesting. Okay. Now we'll say, what's your favorite number? We'll convert it to an integer. And here we want to do some questions like if it's bigger than something else or whatever. So if num is less than 0, you can say elif num equals 0. Else so that else we know your number is positive because it's not less than 0 and it's not 0, so it must be 1, 2, 3, 4, 5 or something like that. So that simply introduces the less than sign. You can do other things like less equal, like this, and that would mean it's less than or it's the same as 0, and so forth. Let's just see how that runs. Oh, I had a mistake. That's fun. Doesn't like if num's less than 0. So this is a classic kind of Python error. It complains about this line. There's nothing wrong with this line, actually. The error was actually the prior line because my parentheses are not balanced. So you're going to see that a lot in Python. You get an error that talks about some other place, usually the next line. So just look around your code to try to find what the problem is. The problem with this parentheses, like it was okay with the missing parentheses until it hit a colon, I think it is. And it's like, whoa, I can't do that. So technically that's where the error occurred, but the real reason is because of this. So green, and then I'll say 0, odd choice, say negative 100, negative number. I'll say 202, positive. All right, now we can actually make a little more complicated of an if by putting an if inside of an if. And here's an example of that. Make sure it's tabbed, otherwise it's not really inside. If num is less than 5, or say 10, we'll say it's very negative, I guess. And that's it. We don't, whoops. Need to undo that. I'm not sure what happened. What is undo? It says can now unjustify. Control U. That didn't do anything. Get help. Control G. All right. Let's see if there's undo. Undo is MU is really Alt U, or Escape U would be okay too. So Control X, go down this, Escape U. Undid action, line join. Oh, I did one too many. I tried that unjustify, and that was in the undo. So perhaps undo would have worked in a different situation, but I fixed it. All right, so the point is, if number is less than 0, you get wow, negative number. If it's also less than 10, it says very negative. So the idea is this if will never be examined if that one's not true. So you only get here if this is already known to be true. So that's how an if inside of an if works. And you can do all the things. You can if, else, elif inside an if, an elif, or whatever. So let's see what happens there. Oh, I have a, oh wow, the whole file got justified. That's bizarre. You gotta be careful what you type, I guess. This else is bad. Yeah, so be very careful about Control J. Apparently that's what I typed. It'll just mess up your whole file. Undo might work if you don't type anything in between. All right, I'm going to save it. I'm going to try this now. If I justify, then I can unjustify. But what if I do escape U? It seems to undo it. What if I justify this one? No, it didn't do anything. If I justify this one. All right, so that messed it up. If I do escape U, it undoes it. So the idea with undo is you can't do anything between. You got to undo right away. But that should work. Okay, anyway, save it, quit, and run it. What's your favorite color? Green. And then if I do -20, I get both messages. Because I get the message from being less than 0, which happens here, and then it asks a further question, and if so, I get a second message. So if I do just -5, I won't get the second message. All right, so, oh wait. Oh, this is another kind of classic mistake. I said num less than 10. Well, if it's already known to be less than 0, of course it's less than 10. So I always get this message because I made a mistake and I should have done less than -10. Let's try that again. Shows the importance of testing, right? I thought I was good, but in fact I needed to test more numbers. By the way, this is where fuzzing fits in. Your code may be broken because no one ever tested some weird case. So fuzzing, where we just generate often random, but not always random, data to feed into a program, can often find those issues that nobody realized were in the code the whole time.